Our cos brackets theta minus 2 pi over 3 equals 2. So let's, first of all, then let's mark off theta equals 2 pi over 3. So let's just draw a line from here, say, up to here at the angle in question. That's the angle we want then. Just put the line a bit more accurately, like so. And that's 2 pi over 3 here, this angle here. So let's put that in. And that's round at 2 pi over 3. Now let's draw an angle r and theta then. So we'll come out from this same spot again. And we'll come out theta this time. Let's just suppose that's theta. And then we'll drop a perpendicular here so we know what we're doing. Now we can label this. This is r. This whole angle here we can call theta. So the difference in the angle, which is here, will be theta minus 2 pi over 3. And then r cos 2 pi over 3 will be this distance here, which is 2. So there's a point then. So we can put a little point here. And we know that if we draw any such triangle along here, right angle triangle, so this is 90, then we're going to have a line along here, aren't we? So why don't we draw that line in? So it's a line that's from here out along here, and it's infinite length. So there we go. So let's draw that. Okay, so that's that half of the line, and that's generated. That was generated by allowing theta to vary from 2 pi over 3 round to 2 pi over 3 plus, and it can go up to almost 90 degrees, can't it, to get these end points as it goes down this way. And that's what line is generated by this here. On the other side, we'll draw another triangle then, shall we? So let's just carry on this line in the hope that we're on the right track. So I'm going to come back over here now and try and draw another line if I can, which I'm going to have to move because it's not in the right place. So there. Okay, let's just move that line so it's joined on. And I think I'm probably going to move some other things, but it doesn't matter. There we are. So there's the line then. Now let's connect that to the origin, and we'll see what happens this side of the line, shall we? Alright, there we go. And let's drop a vertical there. Now what we'll do is we'll mark off that now. So let this be our new theta value. Say this is our new r, and so this angle, this is a right angle in here, so this angle in here now is what we're thinking about, and that angle there, which I'll put a line on, an arrow, that's the value 2 pi over 3 minus theta. So if we do r cos of this angle, brackets 2 pi over 3 minus theta, it will equal 2 if it's on this line. But the good thing about the cosine is that it has the property cosine minus x equals cosine x. So by invoking that property, you can flip those two things around and we end up with what we wanted. So yes, indeed, that's true. This half of the line is generated by theta being allowed to vary from, this is 120, so from 30 round to 120, and from 120 add 90 round to 210, we generate the line going in this direction. So from 30 round to 210 we said, didn't we? Now when we go from 210 round to 30, from here to here on the other side, we're also going to generate the line again, and we'd have to look at that more closely to see how it maps onto the half lines. But I'm not going to worry about that too much here. Let's just that's enough, sufficient for now to have a look at that and to draw the line. So let's have a look at the plot then. See if our plotter can do it. R cos, yeah, I've done it already. I've done it in, and it's reached the limit of the software, I think. Here, r cos theta minus 2 pi over 3 equals 2. Go from 0 to 2 pi. Then you can have a closer look at that if you want by breaking down these bounds and seeing if you get better plots. But that's all that this will give us in this instance then. So it confirms this line really that we've drawn, which is more appropriate, more accurate.